Cast is now starting. All attendees are in listen-only mode.
Hello, everyone. My name is Haley Cassidy, Americhem's Global Branding and Digital Marketing Leader. I'd like to thank all of you for joining today's webinar, Antimicrobials and Plastics 101, which is where we will be talking about making items around us inhospitable to microbes. So I just wanted to let everyone know all attendees are muted, so please send in your questions through the questions tab today, and we'll be addressing them at the end of the presentation during our Q&A portion. So today we will start with a brief introduction of our panelists and who Americhem is, then followed by an overview of antimicrobials, what they are and how they work, and then we'll dive deeper into how antimicrobials are used in polymeric solutions, such as compounds and masterbatch applications, which is what Americhem offers. We'll also be talking about the designing of antimicrobials into these solutions and how we perform testing and efficacy measures. Lastly, we'll touch on some regulatory demands and finally take your questions that our panelists will be answering. Today, I am joined by Matthew Miklos, Americhem's Vice President of Global Technology and Innovation, and Dr. Vaman Kulkarni, Americhem's Global Director of Technology and Business Development in Fibers. I will now turn it over to our panelists for them to give brief overviews of themselves, followed by the rest of the presentation.
Well, thank you, Haley, and good morning to everyone. My name is Matt Miklos. I'm the Vice President of Global Technology and Innovation with Americhem, and I've spent the last 6.5 years with Americhem with a really strong focus on these types of performance functional master batches, critical color master batches, and fully compounded product solutions. Over my 33 years in the industry, I've spent time with LNP Engineering Plastics and GE Plastics, where there was a strong emphasis on automotive products and performance industrial products, and with Schneller LLC, which was a strong emphasis on commercial aviation interiors and mass transit interiors, all of this in performance polymers, composites, decorative laminates, but overall performance polymer materials. I'm going to turn it over to my colleague, Dr. Vaman Kulkarni. So, VG.
Thanks, Matt. I have over 35 years in the plastic industry, primarily in the area of material science and plastic processing and compounding. 30 years plus at Americhem, and over the last 20 years or so, I've been working heavily in the area of antimicrobials as well as plastic additives. Back to you, Matt.
Thanks, VG. Of course, feel free to connect with either one of us or Haley on LinkedIn. You'll find our direct Americhem emails on the screen now, or again, find us both on LinkedIn, and there'll be more contact information at the conclusion of the presentation. We want to give you a brief overview for context about Americhem before we dive into the subject of antimicrobials. So a little bit about Americhem. We're a performance compounding company specializing in critical color master batch, functional master batch, and fully compounded product solutions, all in the polymer space. We've done this for over 77 years as a company, all while being a privately held organization. We have 900 very talented individuals across the globe to help service you. And ultimately, we like to say that our goal as a company is to help you make your application and your material look good, feel good from a haptic standpoint, process well in your finished process, and endure in the finished application environment. And that's very much applicable in this space of antimicrobials, making those surfaces inhospitable to microbe growth. A little bit about our markets and applications. I'm going to start first with our legacy products of performance master batch, and you'll find those largely in the fiber space, where we are a key supplier to many of the large carpet manufacturers, nonwovens producers, performance textiles, and of course, artificial turf. Furthermore, in the transportation space, where we work with many of the tier ones and OEMs on interior and exterior products for the automotive industry, but also are very prevalent in recreational vehicles and the heavy truck market. Moving on, furthermore, in the building and construction space, where you'll find our products in cladding or siding products, decking and fencing, roofing and railing, window and door applications as well, where we'll be selling either performance functional master batches for UV stability and custom color, found in capstocks and other types of compounds. Finally, in the packaging, film, and sheet markets, our engineering compounds group is really going to be found more in the spaces of healthcare. Most prominent would be surgical devices and instruments in the medical space, pharmaceutical dispensers and tubing applications. In the aerospace industry, again, in aviation type interiors, mass transit interiors. And of course, in the energy space, where in performance films, oil and gas segments, and chemical processing segments. This is a quick look at our locations across the globe. I'm speaking to you today out of our Cuyahoga Falls, Northeast Ohio, United States facility where the STAR is located. Vijay is joining us from Pune, India, and technology is enabling us to present this to you globally. So all in all, 10 manufacturing facilities across the globe. I did want to draw your attention to some of the key certifications that we have, quality certifications and management systems. With the audience that we have today looking it over in advance, many automotive companies, many medical companies and fiber companies. Two that I'd like to point out are the IATF 16949-2016, which is our quality management system for automotive, and the ISO 13485 quality management system for medical products, which you'll find at our locations such as Mooresville, Pennsylvania, and Suzhou, China. With that, that's a brief overview of Americhem. I'm going to turn it back over to my colleague Vijay, who will dive into the subject of antimicrobials. Vijay?
Okay, thanks, Matt. Okay, let's begin with the very basic question: what is a microbe? Simply put, microbes or microorganisms are tiny living organisms that are too small to be seen with the naked eye and can only be seen under the microscope. There are various classes of microbes. The two of the common ones are bacteria and fungi, and they're all around us and far outnumber the human population on Earth. And given the right conditions, they multiply very quickly. So why are we concerned with the microorganisms on plastic surfaces? If you look at the plastics today, they're used in a wide range of applications, from food preparation to water handling, as well as air filtration, and in many medical applications. And many of these applications, are in atmospheres wherein microbes can grow easily. And having a inhospitable surface of plastic that can resist the microbial growth is an effective strategy in fighting microbes. So let's look at some of the factors that are driving the use of antimicrobials. First, if you look at it, synthetic fibers and plastics are used in a wide range of applications. Secondly, today's consumer is very educated, demanding freshness in everything that they touch during the day or buy. And then the advances in the antimicrobial materials as well as technologies for incorporating them into plastics. And then lastly, fighting biofilms in industrial applications. See, biofilm, occurs when uncontrolled bacterial growth and becomes a large population. And in many equipments, especially water handling, ice makers, or others, clogging is a very common problem of a biofilm formation, in addition to odor as well as staining. So let's look at some of the antimicrobial additives that are available to us. A textbook definition could be something, a chemical or an additive that resists microbial growth. You have both organic types as well as inorganic types of antimicrobials. One of the most common household names is triclosan, which you can find in the most common soaps and hand wash materials. And the other classes are, the quaternary ammonium compounds, commonly referred to as QACs, and there are other classes also. And more recently, some of the plant extracts have been used as a control against microbes. From the standpoint of compounding in plastics, the organic antimicrobials have a limitation on the maximum temperature that they can sustain. So they're good for plastics processed roughly about 240 degrees Celsius or so. So when you come to inorganic, on the other hand, you have materials based on silver, copper, and zinc, and they're highly thermally stable. So if you have an antimicrobial application in an engineering plastic or a synthetic fiber, which are processed at high temperature, the inorganics are the best choice of materials. Then if you look at silver, silver has long been used as an antimicrobial agent, and then shows a strong efficacy against bacteria in particular. So when we design a polymeric antimicrobial solution, we look into several aspects, and we commonly question our customers with a whole range of questions. What is the intended use of the end part? In what environment it is going to be used? What is expected of the product life? The spectrum of efficacy, for example. Are we dealing with bacteria, or are we dealing with multi-organisms such as bacteria or fungi? And then are there any food contact or water contact kind of considerations? And then the antimicrobials are regulated materials, so we have to take into consideration the guidelines from various regulatory bodies such as EPA and FDA in the United States and BPR and EFSA in Europe. And then a host of polymer specific, especially if transparency is desired in the end article, if they are going to be used outdoors, for example, whether there are UV requirements, and then yellowing of the part and etc. have to be taken into consideration. And lastly, the dispersion, especially when you're dealing with very thin films or very fine linear textiles, the dispersion quality has to be extremely good, and so that you don't have any processing challenges. So having designed an antimicrobial product, how do we go about testing or understanding the efficacy of these materials? Both qualitative as well as quantitative tests are available to us. From the standpoint of quantitative analysis, the JIS 1902 or the AATCC 100 are typically used for textiles, and the JIS 2801 or the ISO 22196 are typically used with hard plastics. And the G21 is the most common test that is used for resistance of plastics against fungi. So in this slide, we are showing you some of the standard bacterial as well as fungal strains that are used in testing. And the results are typically given as % reduction relative to the control or the untreated sample. And in some methods, a log reduction is also used. So 90% reduction is equivalent to log 1, 99 is log 2, etc. So next we will look at a couple case studies of antimicrobial product formulation. This one was for a polyester filament application. If you consider as an industry, the results will be applicable to all synthetic fibers, be it filament, staple, or PCF. And the choice here was the customer was using a topical treatment, and they wanted to develop an antimicrobial with built-in protection. And for this application, we used a silver-based additive from product from our N-Shield product line. And the finished products can be used in a wide range of industries, from athleisure clothing to performance apparel to intimate apparel, as well as traditional textiles and carpets. So here we are showing you the antimicrobial efficacy of a polyester textile fabric. As you can see from the chart there, we tested at 3 different levels, 3, 4, and 5% of the master batch, and we compared it with a control polyester fabric that did not contain any antimicrobial. And as you can see in the last 2 columns, the untreated sample showed no efficacy against either bacteria, the gram-positive or the gram-negative bacteria. On the contrary, you see a slight increase in the number of bacteria related to the inoculated number. And the treated samples you see show a very high efficacy against both the bacteria, greater than 99.9 or log 3. So it's a very good test result here. So next we'll move to a molding application. I will turn it back to Matt.
Well, thanks, VG. So you just heard about antimicrobial efficacy in a fiber type application. In this case, we thought it was appropriate to highlight this particular molding application. And in this case, this is injection molding. And we worked with a company by the name of WeatherTech, who is made famous for their aftermarket automotive products, such as car mats. And they had an entry into the pet industry. So what we're showing here is a pet feeding system whereby you have a rigid polypropylene injection molded stand application, which combines polypropylene custom critical color master batch and the functional master batch of antimicrobial antifungal additives, and a mat separate application, which is an 80 Shore A TPES type elastomer, critically color matched to the stand, but with also that antimicrobial and antifungal efficacy. So really the issues at hand here were they wanted protection against fouling and discoloration that may be due to microbe growth. You see, these devices or these assemblies might be in your kitchen, in your mudroom. They want the assembly to not only match the decor, but to not have any odor or discoloration as a result of microbes. And so that was the reason for the functional additive request. We combined that with, in both master batch products, critically colored and fully compounded thermoplastic elastomer in that base product. So that would be our Severine TPEs and of course our custom color master batches. It would be important to note here that in addition to those critical to quality functions, the customer here wanted to promote this as NSF compliant, and to do so we had to use FDA compliant raw materials. And so it's important to note here, you can combine these antimicrobial, antifungal additives and still maintain an FDA compliant type formulation. So this has been very successful. You can see this case study and more on our website referenced here on the slide. A little bit about the efficacy of this particular application. Here we're referencing the standard ASTM G21 2015. You heard VG talk about that as the fungal resistant test. This was done over a 4-week period of time against various fungi species. And in this case, this is what's shown in the images here is the thermoplastic elastomer, which is used for that base application. The control specimen or the untreated specimen is shown in the top image, and you could see after a period of 4 weeks a significant increase in fungal growth over that surface, whereby the treated or fully compounded in antimicrobial and antifungal solution is providing very good efficacy and very limited to no fungal growth on that particular sample. So we felt this was a very good example. These are very commonly used materials, polypropylenes and thermoplastic elastomers, not only in the consumer space, but in automotive interiors, you'll find these materials, and certainly we can employ these solutions for such applications. Back to you, Vijay.
Thanks, Matt. Applications. Now, if you look at it, the applications for antimicrobial are only limited by imagination. We have shown a few examples here in personal hygiene, office equipment, as well as medical environment here. And in a wide variety of plastics are used in these applications, from synthetic fibers for sheets, curtains, etc., to a wide range of molded articles which utilize olefinic materials such as polyethylene and polypropylene, styrenic materials, polycarbonates, and engineering polymers. And we have custom solutions for most of these plastics in those applications. In this slide, we have a whole lot more application areas. Again, as I pointed out, imagination is the only limitation here. On the top right, you see the transportation in general. Shown above is the aircraft interior. Similar application can exist for automotive interiors, food preparation areas, gym areas, in all the equipments and handles that we touch. Typical shopping, including carts and many other articles that are used in shopping. Household environment, the various surfaces, as well as durable goods, like refrigerators, washing machines, and etc. And then office environments, the office equipments, be it printers, copiers, work surfaces, and etc. And in the medical area, you will have anywhere from medical textiles to equipments to handheld equipments and surfaces. So again, the applications are only limited by imagination. So earlier in the presentation, we talked about antimicrobial materials are regulated materials. And regulatory compliance is one of the key attributes that we consider in designing an antimicrobial solution, be it the type of use as well as the geography that is going to be used in. So in the United States, they are registered with the EPA, and in Europe, the BPR, and Americhem uses EPA or BPR registered antimicrobial additives in our solutions.
Well, thank you. Thank you very much, VG. And that concludes the overview presentation, or Antimicrobials 101 type presentation. I'm going to turn it back over to Haley for instructions on how to proceed with contacting us and questions.
Thank you, Matt and VG. That was a great presentation. We will now move on to the Q&A portion of our webinar. I'll be reading off the questions that have been submitted so far and pass them on to our panelists for answering. So our first question today is, if I use antimicrobials, do I have to label my molded product as containing a pesticide?
VG, you want to field that question?
Yeah. So there are specific guidelines for use of antimicrobials, and these guidelines are very clearly indicated on the EPA website. And we ask everybody who uses this follow the product guidelines for use, as well as claims.
Thank you, VG. Our next question here is antimicrobial the same as antiviral, meaning that will it help during COVID times?
I'll start with the answer here, and then I'll pass it over to VG. Antimicrobial, again, you heard VG talk about the EPA regulatory guidance that we're given, and there's an exemption on the particular code of federal regulations. We could using EPA certified antimicrobial functional additives in the materials, which makes that surface, again, inhospitable to the various types of microbe growth that may be necessary as a host for certain types of organisms. So VG, do you want to expand on that?
Yeah, so basically, I mean, with the textbook definition of microbes, you know, there are bacteria, fungi, algae, and virus is also included under those classes. So our main approach here is making plastic surfaces inhospitable to microbes. So primarily we are not tested anything directly for COVID-19 type of this thing. We have some things under the works that we are planning that. But the basic concept is having made the surface inhospitable to microorganisms, one could possibly benefit from all microorganisms.
So our next question is, was the TPE antimicrobial used in the WeatherTech case study organic or inorganic?
Yeah, thanks for the question. That would be inorganic additives. It's a broad spectrum of additives. There's confidentiality into the specific types, but I can mention that it is inorganic in nature. And in that particular case, the spectrum of efficacy sought out was to prevent fungal growth and to provide an antimicrobial type surface. So so both types of approaches were used in that broad spectrum.
Yeah, and just to add on to what Matt added, you know, so we look at you know, what are the microorganisms that we are dealing with and provide a custom solution for it. And in this case, you know, if you look at even an inorganic material, certain materials are much more broad spectrum than the others. So we choose a custom additive for custom application. So.
Our next question here is, do you have any antimicrobials for bath rug and carpet yarn applications?
The answer is absolutely, both for the face fiber, whether that be PET based, which is most likely the case, or olefin based, and even for the backing potentially. But VG is an absolute fiber expert, so I'll pass it over to him for some more comments.
Yes, we will have solutions for both all types of fiber applications.
Our next question is, how about automotive interior performance in regards to antimicrobials like VOC or odor?
That's a very good question. We have multiple developments underway for the automotive interior space. We don't anticipate any negative consequences in both of those cases, odor and VOCs, based on the types of additives that will be used. I think what will need to be carefully considered are, you know, the type of application, the type of carrier used for the functional additive will be critical for us to help consult on that, the loading level as well. See, when you use these products, typically, especially in an automotive interior, you're going to be dealing with critical color accuracy, UV stability, long flow lengths, and the absence of any type of splay, flow lines, et cetera, are going to be critical. So So the careful consideration of how that's added in the compound, the types of carriers that are used, and the types of additives will be critical. But VG, I don't anticipate a negative consequence on VOC and odor. Do you have any comments on that?
No, I don't expect either. You know, if you recall, there was a slide on considerations for designing the antimicrobial. So in this particular case, you know, being an automotive interior, we would have taken into account the VOC, and we would use only those additives which do not pose a problem with VOCs.
Yeah, most likely I would think that we'd be on the inorganic side. You know, any of the odor type generation in some of those applications are typically the result of some type of degradation. And you definitely want to be sure we're stable at the types of polymer temperatures it's going to see in the process.
Yep.
Our next question is, are there any negative effects with use of other additives such as UV or flame retardancy with the addition of antimicrobial additives?
You want me to take this, Matt?
Yes, please, Vijay.
Yeah, you know, these can be combined with many traditional plastic additives. In rare cases, you know, when you are making a multi-attribute products, meaning more than one attribute is in the finished product, in addition to, for example, the antimicrobial and UV stability. And if you have to build in another, be it flame retardant, sometimes we have to look into the interaction of the different materials and choose the right additive and technology, so there is no competition between these materials or compatibility issues.
So I do want to jump in here. We are at our 30-minute time limit, but we have a lot of questions coming in that we'd like to answer for you. So we will continue for another 15 minutes to 9:45 a.m. Eastern Standard Time. If time permits that you're able to stay on the webinar, please do. If not, we will be posting this recorded presentation on our website early next week. I'd also like to mention briefly here how you can ask us further questions after the webinar is over. If you have any other questions, you can certainly connect with our panelists on LinkedIn. You can also go to the Americhem website and ask us questions through the instructions on this slide. If you go to the website link displayed here, which is simply our Americhem homepage, you can go to our Contact Us page and scroll down to the Contact Us form. Please choose the form that states I have an inquiry, and then choose the option to send the contact form to marketing. I'll be receiving all of these requests and questions directly and be following up with them as soon as possible with our panelists. You can also take a screenshot of these directions, but we will also be sending out a follow-up email with these directions in an email that also contains a link to our contact page. So now I'm going to continue with the questions that we do have coming in here. So the next question is Americhem also working on solutions for viruses?
Vijay?
Yeah, we are planning, in the current situation of COVID, we are planning some tests against efficacy against viruses. We don't have those results yet. So in due course of time, we may have some results back from this. So we'll update it at that time. So as of today, the tests are in progress. We don't have the results yet.
What is the longevity of the antimicrobial additives?
Yeah, I'll start here, and if VG wants to add to it. So because we are not using topical additives, we're using functional performance additives in the compound or master batch itself, and therefore it's built into the compound. So the longevity should be for the life of the application. VG, any more to add on that?
Yep. So again, we take the longevity into the consideration. Generally, they're designed for the life of the article. In case of textiles, it is customary to test efficacy on 50 washings. So we have results which show very good efficacy on laundering with a very minimal reduction in efficacy after 50 washes. So, and or anybody interested, we can have a dialogue and share those results.
So we have a similar question here, but based more towards outdoor applications. The question is, what is the expected lifetime of the antimicrobial functionality in outdoor applications? Our customers demand to know how many years we can guarantee our products will be mold free.
You want me to take?
Yeah, please, Vijay.
Okay. So again, as I said, to the, we consider these issues, and we design products to last the life of the article, whether it is indoor or outdoor. But one of the key things to note when doing an outdoor, plastics are not stable to outdoor because of sun and UV radiation. So there is degradation occurring if degradation occurring on the plastic material itself. So one has to consider not just the antimicrobial, but the entire package that gives the performance that is needed for outdoor applications. So.
Yeah, I think it's important maybe to add to that, VG. Many people on the call probably know this, but Americhem does specialize in functional UV weathering performance additives, as evident in the market page that we showed. So we are prevalent in many building and construction applications, as an example, or exterior automotive, where we test both accelerated weathering and outdoor weathering to many of those industry standards. So we'd be happy to embark on such that type of testing with a compound or master batch that has this efficacy as well as the UV stability.
Yeah, thanks, Matt, for covering. Just to add on a couple more thoughts to this one. Again, these are the type of questions we would, whenever a new application comes in, would sit down with the customer and list out what all the requirements in addition to the antimicrobial efficacy, and we'll design a custom solution to perform under those conditions.
Our next question is, which additives do you supply that comply with EU BPR legislation?
Yeah, that's the biocidal and pesticide regulatory for Europe. VG, you want to field that?
Yeah, so it's not the question of which additives we supply to BPR regulations. Even under BPR, there are many subsections. So whether it is a general one or certain additives are okay for food contact and water contact, and certain additives are not. So you have to look at the guidelines and what materials. So based on looking into all of that, as I pointed out, the regulatory requirement is one of the key considerations for designing the antimicrobial plastic solution. So we would take that into consideration during design. So there is not one particular additive. So.
Our next question is, do the additives affect recyclability?
I'll take a stab at that. And again, if you want to jump in, VG, I would think not. These additives, you saw some of the loading levels that VG was talking about earlier in the presentation. The particle size of these functional additives are such that, and the stability of them, especially on that inorganic side, let's take the TPE example or the polypropylene example, those should be able to be reground, reused into a follow-up application as they would be without the antimicrobial, antifungal type additives, and still process well. And still be in the product. Now, I guess it would be important to note, if you're going to recycle it and reuse it in an application, if you're only using a recycle, let's say at 10% of the final, you're going to have less of those functional additives, and you may have to fortify the rest of the compound, if that makes sense, in order to have the full functional efficacy. VG?
Yeah, Haley, can you repeat the question? I missed the initial part.
Yes, do the additives affect recyclability?
Not that we know of, but recycling and recycling stream is a unique question. So one has to take into account overall conditions where it is going to be used and etc. The recycling products. So yes, they can be, but more information is needed to answer that question. So
our next question is, what, if any, impact from the various sterilization methods on these various antimicrobials is there? Do you have any studies related to sterilization methods on your antimicrobials?
I do not have experience in that area. I'm sure our engineering plastics group, which specializes in medical equipment, can probably field that, and we certainly can follow up. VG, I know there's various sterilization methods, steam, gamma, and others. Do you envision any detrimental effects?
Yeah, again, the type of, and this is one of the areas that we would ask, are there any special considerations for the antimicrobial? And we would use only those additives in this application that would withstand the sterilization. For example, certain organic chemicals or topical coats may or may not withstand the conditions of sterilization. So more than likely, it will be an inorganic solution. But again, we would take that into consideration, which particular additive to be used in such applications.
Please do get in touch with us after the presentation. We'd be happy to explore that further.
Our next question is, if these additives are used in TPEs, will they pass automotive testing?
That's the objective. So we have been embarking on multiple applications with such additives for automotive interiors. In the past, there hasn't been a strong requirement for such products on automotive interior, and of course now there's much attention to this matter. So we have a number of customers, and we are working on specific compounds and master batches to perform in automotive interiors. So we'll have a lot more information in the months to come. We envision they will, and as we said earlier to an earlier question, we don't envision too many detrimental effects to those critical to quality automotive requirements, VOCs, odor, and aesthetics. But all that testing is underway.
Our next question is, do antimicrobials inhibit foul odor coming from products due to the growth of fungi?
VG?
Yeah.
Again, go back to the efficacy pages where you had those significant log reductions or percent reductions of the number of microbes after subjecting the control to the inoculation. It's significant. And so if the odor is being generated by those multiplication of those microbes, certainly we are reducing that.
But by and large, the foul odor that we normally see and associate is primarily coming from bacteria. But the antimicrobial solutions are designed to work against both the bacteria and fungi.
We have two similar questions here that I'm just going to combine into one. Are there certain specific polymers that do not respond to antimicrobial additives? And is the same additive used for both PE and PP resin applications?
VG, you want to try that first?
Yeah. I mean, there are many additives that we could use that are common to PE and PP applications. So I don't see that to be an issue there. So
yeah, one thing I would add to that. I'm sorry, VG. I'll just interject on the PP and PE. Keep in mind, it'll be much like if you were designing a custom color master batch for those same types of products. You would want to control the rheology, for instance, so you have the proper distribution and dispersion and melt coming into your machine if it's an injection molding application, for instance. So so the type of additive, the functional part of that additive may be the same. But we would put the rest of the master batch together to make sure it performs in the molding or extrusion application, for instance. I forget, there was a second part of the question.
Yes, the first part was, are there certain specific polymers that do not respond to antimicrobial additives? And the second part was, is the same additive used for both PP and PPE resins?
I think we answered the second part of the question. So the first part of the question, are there any polymers that do not respond to? We have not come across, again, there are different antimicrobial additives that respond to different environments better. So this is again, that's where customization comes. We would need a little bit more details on that to answer that question fully.
Yeah, outside of the thermal stability, for instance, you're not going to use an organic plant extract, for instance, in PEEK. It's just not going to survive that type of temperature and processing. But next
okay,
question.
so we're at our 45 minutes here, so that does wrap up our Q&A portion of the webinar. I'd like to thank our panelists for their time today, and I'd like to thank all of our attendees who were able to join us and join for the additional 15 minutes in this important discussion about antimicrobials. Thank you again for attending our webinar today, and that concludes our presentation.
Thanks, Haley.
Thanks, everybody. Thanks, everybody, for joining.